Hello, everybody. Thank you very much for joining today's webinar for a demo of ComPredict's end-to-end virtual census platform. I would like to start with a little bit of housekeeping. We would like to have this webinar for 30-40 minutes approximately, depending on the questions. For example, the webinar is being recorded today, and it is going to be available as replay afterwards. We would like to make it again a bit interactive, and we will use Slido for this. Please have your mobile phone ready so that you can scan the QR code of Slido afterwards, and that you can join us in Slido. At any time, you can drop your questions directly in the chat function of this webinar or from your mobile phone in Slido if you prefer to ask questions anonymously. Now, let me hand over to our speakers. Let me welcome Daniel and Martin.
Hi everybody from our side as well. My name is Daniel Dilmetz and I'm responsible for sales and business development here at ComPredict.
Hi, I'm Martin. So I'm head of domain expert team by ComPredict. So this means data science team with more mechanical engineering background, I would say. And you maybe know me from the second webinar.
Yeah, exactly. So maybe let's take a short overview of what's going to happen today. So the first webinar, as Katrin said, we want to keep this as interactive as possible. So if somebody out there who is feeling tensed from our talk today, so make sure to drop a comment, make sure to contact us after the webinar. But especially if you are in the business of vehicle testing. So we would
love to know if you are already aware of the issue we can see during a testing track day or testing events and so on. So if you are used to such situations, this will be really interesting for us just to know your experience. And of course, the webinar is designed, if you have no idea about testing, this is not an issue at all. We will try to involve you, to give you all the possible keys for this.
Absolutely. So we are going to take you from our whole process, like from the start from data collection to the actual visualization of insights. Therefore, let's take a short overview of what is going on today, maybe. So you maybe know this is our third webinar today. So in the first webinar, we were actually talking about our participation within a certain project. This was alongside with EDAG and their CityBots. And the second webinar was some insights from our side on how we are actually starting a data science project, where are the issues there and how we deal with them and stuff like that. And today we want to give you some sort of a little bit more active approach and insight on our solution, our technology here at ComPredict. So basically, we want to start. Maybe you missed the first two seminars, but you can watch them on LinkedIn as well. So maybe you give it a look after the webinar or whenever you want. And for those of you who haven't heard of virtual sensors at all, we want to give you a short introduction on what a virtual sensor is anyway, how it can be used. And then we are starting, as I said, from the beginning, so from the data collection point. So we prepared a little video for you on this point. Then we will talk about a little bit about the transfer of the data, so from the vehicle to the cloud in this example. And afterwards, we will give you insight on our AI View platform, so on our visualization platform, where all the insights that we collected in the first place are then displayed for anybody who's interested in. So it can be the engineer, for example, or the fleet manager. We will talk about these use cases and where our technology is applied today already, but how it and where it can be applied in the future. Of course, too. Maybe let's start with short introduction on virtual sensors, right? So Katrin, maybe you can put the first slide on it. Yeah, absolutely. So vehicle testing. I mean, this is an issue especially for OEMs, right? So and we all know how production and development cycles evolved in the last couple of years, and they shrink, so to say. So and especially when we talk about vehicle testing, it's a very time-intensive situation, a cost-intensive situation as well. And on these specific days, like everything has to work fine, right? So especially when we start, at least with the amount of data that the engineer has to take care of. So nowadays, vehicles are producing tons of data because tons of sensors are implemented in this vehicle for a certain job, right? I mean, there are sensors that measure the wheel speed or the steering angle and stuff like that. And this is going to be increased in the next couple of years as well, right? So, and when we are dealing with test scenarios, I mean, there obviously can be the situation that you have a test track for only one day, and therefore everything has to work out. So, and when you think of a hardware sensor today, then you will think of something that is pointed out in the first or in the upper cycle in blue. So it's some sort of small hardware device that is responsible to measure something. And of these sensors, in nowadays cars, we are talking about 100 to 100 sensors for a car, even more. And they are, as I said, producing huge amounts of data and therefore huge amounts of information as well. However, the information of these sensors can be combined together, and we maybe get some more out of it, so to say, some exact insights on the vehicle condition and situation. So from a macro perspective level, so the condition of the vehicle itself, but also from a component side, so a little bit more detailed side, so we can actually see how a specific component is doing in a certain situation, for example. And this is where we come in, as we, as ComPredict, use our virtual sensors, so intelligent algorithms, to combine the information of these sensors that are already implemented into the vehicle, and as I said, combine them intelligently to get more out of these vehicle data. And with this technology, we are able, for example, to reduce the total cost of ownership, because when we think of vehicle testing, we are not only discussing about the sensors that are implemented in the vehicle anyway, but they are equipped with certain amount of additional sensors for any kind of situation. So mostly for dimensioning of vehicles, so to say, or dimensioning of components. And these sensors are very expensive, but we will come to that later. Of course, with our technology, we can eliminate risk in harsh operating conditions, for example. This is one very interesting thing as well. And of course, because our technology is very adaptable to it doesn't care if it's 5 cars or 50 cars or 500 cars. We can definitely accelerate test campaigns, make development cycles more efficient, and and another thing, of course, is the scalability to a number of vehicles, because when we talk about additional sensors for vehicle testing, these are very expensive sensors, as I said, and they are not scalable to a huge amount of fleet. And with our technology, we enable things like that. But I mean, it's not only this case, right? So there are plenty of other problems and situations when we talk about vehicle testing.
Exactly.
Right?
On vehicle testing, especially if you, for development vehicle, I will specify for this case, you are trying to understand exactly the behavior of the vehicle during the drive. So as an engineer, we want to add additional sensors. So here we are speaking from laboratory sensors or lab sensors, which are first very expensive, very sensitive, very precise. But the idea is you have to mount them additionally to the car. So you have to modify your car. And this can be difficult. For example, because you can change the geometry of some components to add this sensor. So your car will not behave exactly the same way because it's different. It's a different physical system at once. And then some in place. You cannot mount sensor everywhere. For example, in the heart of the engine during driving, it's impossible. So some measurements are just impossible to make. And then there is also some you have to take care about the conditions, the driving conditions. So first, of course, if there is oil, if there is overheating, something like this, the sensor doesn't like these big differences of temperature. But then you have also the environmental condition from outside. What do you do if it's raining this day? So you book a test track, you have a driver there, and then it's raining. Will you just cancel your testing set or day or not?
Wouldn't be very valuable, right?
Yeah, and this is all situation, or basically moisture on this lab sensor. You know that they will destroy them, and such sensor cannot last for a very long time. So if you are driving really long situations, so for example, really endurance tests where we are speaking from 100,000 kilometers, for example, a lab sensor will not last this whole campaign. It's impossible.
And I mean, not to mention the calibration of the sensor. So it comes out of the box, and it might be sufficient for a specific situation, but as soon as something changes you mentioned environmental changes for temperature and stuff like that, for example. And as soon as these things might change, then you have to recalibrate again.
Then starts the nightmare from the data science, data scientist point of view, because you are measuring stuff which is not trustful. So basically, you just waste money because with time and money, you are not able to use this data, and this is the worst which can happen.
And this is what we think that virtual sensors can solve. So we can solve these problems because our technology is purely software-based. So we don't need additional hardware. So we just are collecting the information that is implemented in the vehicle anyway, combining them intelligently. And this is what we want to show you right now. So especially the applicability. And for this issue, we want to introduce you to our demo car. So this is not only a slide, but this car is actually existing, but you will see that in a minute as well. Martin, can you tell us a little bit something about our demo car?
So the idea is we took a Tesla Model 3 and we transform it to a development vehicle. So this means that we add hardware sensor to it for different components. I will explain it more in detail in the video. But the idea is really with this car, we're able to log data coming from the vehicle. So basically features you can use as input for virtual sensors, and also targets, reference measurement with additional hardware sensors. And the idea is to prove you during a live test, during a drive, that all this hardware sensor can be virtualized. And this is the idea of this demonstration vehicle.
And this is what we actually did, right? So of course, we wanted to show you some insights on our AI view technology. So we therefore had to do some sort of a little measurement campaign in the first place. So we are actually going back in time right now for some couple of minutes. So we actually prepared some sort of video for you to document this little test ride. It's going to be 5 minutes. I hope you will enjoy the video and see you after the video. Hi everyone, this is Daniel, Martin and our Tesla here at the test track in Darmstadt, and we will give you a short presentation of our solution alongside our Tesla today, from data logging to visualization of our virtual sensors. So some of our virtual sensors don't need specific training. For example, our virtual sensors for tire wear, brake wear or the entire vehicle mass can be implemented to any vehicle type or brand right off the shelf.
Virtual sensors for research and development purposes, however, required some reference data for a specific training. These data are gathered by hardware or lab sensors. That's why we decided to equip our Tesla with such kind of hardware sensors. Let me give you some example of the sensor you can find on our development vehicle. First, we equipped the vehicle with suspension displacement sensors. These are linear potentiometer measuring the vertical displacement of the wheel. Then, we equipped the tie rod with some strain gauges to measure the force. A tie rod is the component which is transmitting the movement when the driver is steering to let your wheel turn. And here we are measuring the force in this component. Then we equipped the drive shaft, the rear drive shaft. The drive shaft is the component transmitting the torque generated by the engine to the rear wheels. And here again, we installed some strain gauges with a special technology because the component is rotating.
So now you know everything about our Tesla, but we want to show you how our virtual sensors work. So let's jump into the car and do a little test drive.
Welcome on board.
Welcome on board. Okay, so let's go. So, besides the hardware sensors that we additionally installed in the Tesla, we also installed a very powerful data logging device. It's based on NVIDIA Jetson, which is a very powerful industrial PC standard, alongside a CAN interface with GPS and LTE connection, and a software stack developed by Compredict.
So basically this data logging device is getting data from the vehicle, because nowadays every vehicle is generating a lot of signal, a lot of data, which is transmitted via bus system like CAN bus. So our data logger is getting this signal and using them as input features for the virtual sensor.
Yeah, and I see that right now because I have a tablet here with me, which is directly connected to the data logger.
Exactly.
Yeah.
And you will be able to see three kinds of signal.
Okay.
The first one coming directly from the vehicle, then the one get it by the hardware sensor we presented you before, and finally the virtual sensors computed live. And maybe we can start with the drive shaft torque.
Okay, I'm going there right now.
I will make some maneuvers, some acceleration and braking. You will be able to see some positive torque when I'm accelerating and some negative when I'm braking.
Oh yeah, I see it right now.
Yeah, let's start with some harder acceleration. Be careful, Tesla is a powerful car. And here you see the positive torque.
Yeah, absolutely.
And then when I'm braking, you will see the negative one.
Yeah.
But let's say this is a level 1.
Okay.
We can go to the tie rod, for example, and I will drive a small slalom. And then here you can see the steering forces.
Oh, so yeah, I see them.
Now, sorry, Daniel, is quite uncomfortable, but
it's okay.
You can see that the virtual sensor are able to reconstruct the measurement made by the hardware sensor pretty accurately.
Yeah, it's pretty accurate. I mean, I see both lines from the measurement from the hardware sensor and from the virtual sensors, and they are quite the same. So.
And this is exactly how we convince our customers that the virtual sensors are able to replace a hardware sensor by comparing with a reference. But maybe let's jump also to the suspension. I will drive the same kind of slalom, and you will see when I'm steering, the car is moving basically. So you will see some vertical displacement of the wheel, and you see that we are also able to reconstruct it without any hardware sensor.
Yeah, wow, that's amazing. Cool.
Yeah, so this was the live demonstration, but it's not over. Now this data will be transmitted to the cloud, and with this data we can make some further analysis, some further investigation, and maybe we can demonstrate this back to the office.
Yeah, I mean, we are showing them the data then on the AI View platform, right?
Exactly, on AI View everything will be uploaded. But yeah, then see you then.
See you in the showcase. Bye. So unfortunately, the last seconds were cut out for some reason, but the main situation was then covered. We actually have to apologize as well because it was a very windy day, so especially my hair was going all over the place. But yeah, so for me it was very fun because the only thing that didn't work out quite well were our texts in our speeches, but all the data logging and logging into the device and seeing how the hardware sensors work on the first place and how the virtual sensors were calculated live there, and that was very interesting. So but now let's talk a little bit more about our architecture, right?
Yeah, exactly. And maybe I can explain you a little bit more about the data journey from here in the case of a development vehicle. So here you find on the bottom left, the idea is the vehicle is generating some data, And then this data are gathered, for example, with our data loggers. But it can be also something else. But our data logger solution here called AI Log is a powerful PC.
We know how it works,
yeah,
right?
Exactly. And then this is the beginning of the journey because the data are now gathered. But what do you do with this data? And the first step is to ingest the data and to store them because we are speaking from a huge amount of data. For example, a vehicle driving twice a day, I will say, can generate more than 5 gigabytes per month.
1 week.
One vehicle. So you have to have the right architecture to ingest the data.
Absolutely.
If you remember well, the second webinar, we started to speak about it, and this is one point where we can definitely help you because you have to ingest the data, but you have also to process them, pre-processing, removing the outlier, removing the measurement errors, and there can be a lot of stuff.
And this can be an issue as well because you might have 5 development vehicles, for example, but they might not be at the same place. So
exactly.
One can be in another country, for example. And how do you get the data on one place where everything is stored and the people who...
This is very important, the point that it should be central. It should be one place where everybody is able to access easily to this data. And this is the point where AI Core and AI View are really important. AI Core is our core solution. So it's a computation server which is enriching the data. So basically, you can here run some analysis. You can run some virtual sensor. Once you have some data available, you can enrich this data. Everything is happening on the AI Core, where some powerful machine learning or AI-based model, I will say, can run. And then it's great. You have a lot of data. You have enriched your data. But if the people in the company, if your engineer are not able to access them or are not able to visualize them easily,
nobody wants.
Yeah, nobody wants, and you have nothing. So that's why we developed AI View, which is a web-based platform, a website basically, designed to give the access to the data really easily and with a UI to engineers or at least to non-data engineers. Because we don't want to have ugly requests, SQL requests in a data lake or something like this. No, the idea is I want to access easily and quickly the data to perform my job, to add some value because with this analysis. And this is why we have AI View. And maybe we can jump to the later.
That one point you mentioned earlier is the situation like maybe you find out that some situations are not covered from the measurement rights, so to say. And then you have to adapt, and you have to be sure that there's a solution that is easy and convenient and where you can live, so to say, check if everything of your measurement campaign is going in the right direction. So this is why we developed, as you said, developed AI View to have a convenient solution for the customer here. But we have to mention one point. So this is basically an example of our cloud solution. However, our algorithms or our virtual sensors are also able to be embedded into the vehicle itself. And we already did that on several projects where we adapted our algorithms or our virtual sensors to the specific situation. So we were able to embed them at the engine control unit, for example, or even at the transmission control unit, for example. And this is one important thing to understand. So we are, so we are not selling just one suitcase, and if your stuff is not going to fit in, then you're out. But we are, so to say, adapting this suitcase to the customer-specific needs, right? So there can be certain situations why you need to embed the algorithms into the vehicle directly. And we are absolutely able to do this. But this is just a side note for you out there. Let's dive into the AI View, right?
Exactly. Yeah. Here we are. You are on our demonstration platform. So of course, what we will see are only our data. But basically, as a customer, you will have a similar website, which is only for you. And here, the little bit overview of the data journey. First, you have the visualization of your fleet. Mm-hmm. A fleet, is a bundle of vehicles. So here you can find our Tesla you saw on the test track, and also we generated a lot of 5,000 fake cars.
But for research.
For research,
right?
and just to demonstrate the capability of analysis
Absolutely.
of a large fleet. But here, first you see all your cars which are running. You see what is the mileage, when it was driven the last time. So you have an overview of it, and then you can go one step deeper. For this vehicle, first you can see what is the current health status from several components.
So this is what I was talking about, the macro perspective. So
Exactly.
we can take a quick look on the situation of the vehicle.
Exactly, and you can imagine, so here, for example, I see my winter tires are pretty done. I would say, so as when I manage my fleet, I say, okay, be careful, I have to plan an intervention.
Absolutely.
And you see the complete history of the trips. And here, what is interesting is we can add as many components as we want. So basically, these are the components where we are gathering data for, and we are looking at.
And this is also customizable to the needs of the customer.
Of
right?
course.
So on the first place, we can take the additional sensors, as we mentioned in the video, for example. But in the other case, we can also look at the brake system or the battery.
Exactly.
Right?
So here, let's start with the tie rod. So you saw that we are enriching the data to generate forces, and this is the first step for us to generate a health status and to see what is the current state of health of this component. And basically here, what we are able to see is the history after each trip, after each drive. What is the health status? So here, just 0 is component new, 1 is be careful, I have to go to the workshop.
Yeah.
And we are not stopping at this. This is the current state. This is at the time point T, the current time point. But we are also forecasting the damages and taking into consideration what is the worst driving situation, what is the best case, I would say, the smoother driving situation.
And we are doing that by, so to say, overlaying the actual usage of the vehicle.
Exactly.
And combining this information with the
Exactly.
components.
It's something made of AI core, and each time we will get new data, you have an update which is made, and you will see the value which is updated.
Yeah.
And here, so you can forecast how many kilometers I can drive till the failure. You can also follow what is the kilometers, what is the mileage of these components after each trip with the dates. So this is really wheel-driven data. And you can also, let's jump into the winter tire, for example, because this is a component, basically, we unmount the winter tire at the beginning of the summer, and the tires was really done. I mean, there is nothing, no profile less.
I mean, we have to do some test drives at the test track with the winter tires as well. So obviously,
it might happen that they had a hard life at the end. And here you see that basically we predict that we were only able to drive 500 kilometers until the end of life. And yeah, so here this is something with a component which is with much more wear.
Cool.
And we can also directly gather this data in an aggregated form, which is basically the input for our algorithm, and also something the durability engineers are working on and used to on. And this is one strength of the platform, is we are engineers. We know what the people are using, what are the needs, exactly, what are the requirements. And we try to fulfill it to give the data in a process form, so the people can do directly their job and no more have problems with data.
Absolutely, yeah.
And this is the load collective, it's called, but then we can also go to the trip.
Yeah, I mean, we can take a look on the trip that we actually drove, right?
Exactly. So this was driven a couple of time ago, and basically on the 22th of
April. Yeah.
Exactly. So I have the history here, and I can just click on the trip. And basically, you know what was the timestamp, what was the mileage at the given point, and then I can directly visualize the time series. And here I can add directly some time series for it. So this is the data gathered by the vehicle. So here I have some CAN data and also some virtual sensors. So here, for example, the drive shaft torque, which is we are left, let's say, and And here the idea is you can see exactly what I drove. So for example, let me zoom in. Here I have a nice acceleration. So you see, okay, I have the torque which is positive. Then I give some hard acceleration. So I have a peak in the torque. So let's say if something happened, if you want to understand really in detail what was the situation,
what was going on,
what was going on, to understand exactly what was the behavior of the car, how your component reacts at this given situation, here you can go one at the lowest detail, I would say, to really understand what was going on.
Absolutely. But I mean, Martin, so we have talked about the vehicle condition right now. We have talked about the component condition, loading cycles, and time series, but this is not everything, right? So, so Catherine, maybe you can show the slide of our portfolio again. Absolutely. So, yeah, I mentioned this in the video earlier. So our portfolio is, so to say, twofold. So on the one side, we have virtual sensors that can be taken right off the shelf, right? So we just need the data access or some input data from wherever, and we're good to go. But of course, this is not a core specific value, but especially when we talk about vehicle development.
Exactly.
Right?
Development vehicle can have a lot of custom applications. So, and here virtual sensor can be used for any application. I really say everything.
Yeah.
So it can be a force, it can be a strain, it can be a torque, it can be a temperature,
or
it can be a
light
resistance.
intensity.
Light whatever you want, it's not an issue. And for this, we develop actually an automatic pipeline. So the idea is you give us data, you tell us what it is or not. We can also work with a really agnostic way without understanding what is measured, where in the car, everything. This is not an issue. So, and here you will have a virtual sensor which is trained automatically and then directly usable and implemented on AI View and AI Core. This is totally possible.
Cool. But I mean, this is it, right? This is a short glance. We could sit here and talk for the next couple of hours, so to say. So, but of course we want to have a little bit more time for the Q&A section. But before we do the Q&A section, maybe let's sum up a little bit. So, I mean, the adaptability and applicability of our solution, especially when we think of development vehicle cycles. So what do you think from an engineer's point of view? Who is actually using this technology? Why should he use this technology or she? Where are the valuable things right here?
If you ask me, I would say everybody.
Yeah, of course.
But really, you start logging data with a high accuracy and really a reliable way, because you don't have to lose data. And this is the data culture to build. We spoke in the second way.
Absolutely.
You have, each time you are driving, you have to take care, okay, are my data correctly logged? And can my colleague later, in 2 years, maybe access to the data so we don't waste time and we don't waste money? But here, basically, everybody can use it. So it can be engineers, so they want to access the data, and their work starts with the data and with the enriched data. So here, I will say with any development team in the automotive or the transport industry, I will say, because of course, we are speaking a lot of car, but it can be anything.
Absolutely.
But not only, I would say, I'm thinking about fleet managers.
Yeah, absolutely. So you actually mentioned the whole industry, and this is something that we have in mind as well. So if you think of this, especially the AI View technology, where you see every vehicle and every vehicle condition aggregated to a simple platform that everybody can understand, everybody can access from all over the world at any time, then of course we are enabling fleet management solutions for mobility providers as well. And we, of course, as we take the vehicle usage again, we are offering predictive maintenance issues. We can evaluate the right vehicle choice. We can offer so many additional revenue streams for mobility solutions.
Better understanding your car.
Absolutely.
And this is the strength of a virtual sensor, I would say, to really enable data which are hidden at the first glance.
Okay. Yeah, I mean, we hope that we at least convinced some of you out there. And we would love to hear some questions right now. So Asking you, Catherine, are there any questions already from the audience?
Yes, we've got 3-4 questions. The first one, can you hear me?
Yeah, absolutely.
Question number 2. Is it possible to show the hardware sensors, for example, like the strain gauges in AI view? Because you only showed the virtual sensors. Is that right?
Yeah. We did that at the tablet in the car, but not at the AI view.
Yeah, exactly. So, but it's definitely possible. So basically, we can display any time series. It can be from the vehicle, canvas data. It can be virtual sensor. It can be hardware sensor. It can be whatever you want. Really, there is no limit.
Thank you. One other question, very nice question. How are you decoding CAN? Did you obtain the DBC from Tesla?
Oh, that's always a nice question, right?
Yeah. So I will first give you the typical engineer answer. It depends. Yeah, I will say it's really depends from the situation. So it depends from our customer also. So if you have a full access of canvas data, if you have access to the data, we are glad to use it. I will say it like this.
And this is the time here and there when we are actually working with vehicle manufacturers.
Yeah,
right?
exactly. So here, when we are working directly with OEM, so they have access to the data, this is not an issue. There are some possibility to access some data in a standard way. I'm thinking, for example, about the truck industry, where they have a standard communication protocol. Here, I would say we are not working with Tesla for the moment, so we didn't get the.
Unfortunately.
We didn't get the access to the bus through Tesla, but there are possibility, and we are also used to it to access this data manually. So this means to decrypt the data.
Yeah, or as we always call it, reverse engineering.
Reverse engineering. This is the nice name for it.
Yes.
Our internal term for this.
I guess we do have some practice in that. Another question, how robust are virtual sensors against changing conditions, and how to ensure that virtual sensors are accurate enough?
Very good question.
Absolutely.
So basically, in all data-driven solution, we are as good as the input data during the training set. So this means that if we get some data, usually we are measuring data in the worst case, really the harsh condition, really the worst case, and if we are able to see during the training, during the development of the virtual sensor, then we can ensure later a good accuracy. If you are presenting to this AI-based model a completely new situation, let's say you were only driving in the city and then you go on the highway in Germany without any limits and driving more than 200 kilometers per hour, I cannot guarantee precision.
But I mean, this is essentially relevant for specific use cases, right? So when we are talking about braking conditions, for example, and as you mentioned, this Autobahn drive, when we get a data set of 2 hours of driving 120 kilometers an hour using the cruise control on the Autobahn, without any braking scenarios, so of course this is a little bit harsh there.
I would say there are multiple situations. So of course, so we are monitoring our models. So let's see that if we detect that at a given point we are in a new situation, we alert the user or the owner of the virtual sensor that be careful, the output might not be accurate, because we are able to detect it. And we are also able to detect if, from a statistical point of view, the output is out of bound. So this is something we are monitoring very closely and inform our customer, of course. And there is also a training, continuous training, continuous learning. This is the right term. Is actually the idea is really to see, okay, now my virtual sensor is not performing good because I have a new situation. Let's take some reference measurement for this given situation, retrain the model, so enrich the model, so let it grow, and then we will be better the next time.
But it's an understandable iteration at this point, right? So everybody knows where are we, or where's our current situation regarding the accuracy and the applicability of the technology, and then we can step by step adapt to several situations, which makes it understandable.
Yeah, and basically what I can say is we are able to reconstruct the worst case scenario with, let's say, hard braking and very bad road conditions, or hard acceleration, very sporty turns, some very hard driving situation, and this means that all the common life situations are covered, and here we can be really accurate.
Yeah.
Thanks a lot, Daniel and Martin. Do we have time for one more question?
Maybe one more question? Yeah.
Okay. What if we do not need a data logger because we already have made measurements, we already have measurement data? Can our data be implemented in AI View?
Absolutely.
Yes.
I mean, you can say something.
Yeah, we offer a pipeline with the ingestion and so on, but it's really modular. So basically, you can give us some raw data measured a couple of years ago even, and we will ingest it in our pipeline, or you can take care about the ingestion yourself and just access AI View. You can also just access the virtual sensors. So without any UI or something like this is also possible, just to request the virtual sensor and do whatever you want with the data. We are just offering AI View and all the pipeline as the easiest way and maybe the most reliable and the fastest way.
I mean, when we think, so if we think of a actual measurement campaign of a vehicle manufacturer, this can happen quite easily, right? So maybe they have two development vehicles located in a certain region, and they are already equipped with some data loggers. But maybe they have 2 or 3 additional vehicles placed somewhere else, and they don't have data loggers or different data loggers. And this is, I think, one big advantage of our solution. So the boundaries to actually take something out of our solution and use it from start to end, they basically don't exist. So we take whatever we need or whatever we have in this situation.
Exactly. Always be pragmatic, and we always find a solution.
Good.
Okay. Yeah.
Cool. Yeah, I mean, then thank you very much for the attention. It was an absolute pleasure to speak to you today. Stay tuned for our next webinar. So what will happen the next couple of months and weeks? So there's plenty of things going on. So I was in Karlsruhe at the IT Trans last week, which was a very interesting fair, and it's always good to have a actual fair and being in person somewhere, so getting back to normal life, so to say. You were
I was at the AWS Summit in Berlin to discuss with some customers and see what's going on in the cloud direction. And but there is also a lot oncoming events.
Yeah, next week I, alongside with Katrin, visit the Commercial Vehicle Show in Birmingham. We are going to be at the Automotive Testing Expo, at the VivaTech, at the Battery Experts Forum. So lots of room to potentially talk to us. We would be very happy if you come by at our booths and say hi. Again, thank you very much for the attention, and we hope you'll have a good day and a good rest of the week, and see you in the next webinar.
Thank you.
Thank you very much.
Bye-bye.
Thank you, Katrin.
My pleasure. Thank you for joining today.